Hello class, so it's Sir Capistrano again. This is isomers. This is actually part two of our discussions of isomers. Wherein that on the last video we actually talked about structural or constitutional isomers, and for this one we will be looking into the more 3D or the solid isomers or distinction of isomers, which we call stereochemical isomers. But before that, just a review again. We have here isomers or compounds with similar or same molecular formula. We already discussed structural isomers. So for today, we will be having, or for this video, we will be having this stereochemical isomers. Wherein stereochemical isomers are compounds having the same molecular formula and having the same connectivity of atoms, but they differ in orientation of atoms in space or three-dimensional structure. So for that, we actually have this somehow tedious way. This hindi naman sobrang tedious. But we have here this distinctions. So for isomers, we actually can group them into two. We have the configurational isomers, wherein they differ in three dimensional arrangement of the substituent around stereocenter, wherein they are not convertible through bond rotation. Also, conformational naman, it arises from the rotation of about single bonds. So under configurational, we have enantiomers or mirror image stereoisomers, and we have diastereomers, which are actually non-mirror images stereoisomers, and also we have here our those with stereocenters on our diastereomers and those with uh, what we call C-strands or geometric configurational stereoisomers, wherein they differ in the position on of substituent with the respect of double bonds in alkenes or face of the ring in cyclic structures. And lastly, for conformational, we have staggered and eclipse. I decided to separate the video for this one because somehow this is a long video in that note. So let's start with the configurational isomers, specifically enantiomers. So for and diastereomers. So for enantiomers are actually just mirror images of stereoisomers. So in that, one example of this would be our CH3. Then we have here our bond. We have here a carbon here. Then we have here our hydrogen or oxygen. And also we have here our CH2, CH3. And for its isomer, since sinabi niya mirror images lang, ang mangyayari lang po dito is if we have here our CH3 and we have here our CH2, CH3, we will have here an OH here and our hydrogen here. So that is our enantiomer. So, sir, paano magiging basis yan nung sinasabi nating mirror images? So actually, if we look into this, ang pwede mong tingnan when we are talking about enantiomers are actually what we call the chiral centers. Right? Chiral centers, these are carbons having different substituents or different side chains. So by chiral center, ano ba nangyayari dito? So for this one, if you look into this carbon, kasi tandaan nyo may carbon dyan, This carbon is actually surrounded by different types of molecule or side chain per se. For example, this carbon is surrounded by hydrogen, a hydroxide, a methyl, and an ethyl. So we can look into this chiral center, wherein this chiral center will actually have different types of side chains. Same for the other one. So anong pinagkaiba nila? So ipakita natin ng mas personal. Wait lang. Alright, class. So for those enantiomers, actually I created this once. Alright. So I have here two of that molecules wherein there are actually mirror images of themselves. Medyo hindi ko lang naikot. Ano. But in any case, we have here this molecule. So for this one, as you can see here, here is our chiral center. We have here our metal group. We have here our OH, our hydrogen here, and on the bottom we have here our ethyl group. So same is done with this formula. We have here our methyl group, our oxygen, our hydrogen, and our ethyl. So in that, actually, if you can see here, class, these are mirror images kahit na magkaroon tayo ng tinatawag nating bond rotation. So, halimbawa, parehas ko silang, medyo hindi mahirap lang gawin ano na isang kamay parehas. But if you look into this and parehas ko silang inikot ng ganyan, as you can see here, so ayan. As you can see here, mirror images pa rin sila. Ano? Kahit nagkaroon tayo ng rotation. Okay? So, kapag inulit ko yun, let's say, let's revolve them again. Facing na yung ating, ano ba yun? Yeah. So, facing sa akin, kung makikita nyo, facing sa akin yung isang, yung itong isang OH, and then facing sa inyo yung isang OH. And kapag na-rotate ulit natin yan, ayan, balik tayo rin sa original position. Same will happen kapag yung ang tinignan nating center or kung nasa ibabaw natin per se ay yung ating ethyl group. So, pag yung ethyl group yung nasa ibabaw natin, sure na lang. So, if you look at the the metal group here and the metal group here, magkaharap sila. And also, nakaharap sa akin yung yung mga OH and makikita nyo in both directions, andun yung ating mga hydrogens. Okay? So, these are actually enantiomers. So, kahit bali-balik rin natin sila as long as andun yung orientation or yung meron tayong isang same orientation, kumbaga, kung same yung orientation ng natin, nung mga bagay-bagay, kung makikita nyo rin ito, mirror images silang dalawa. So, basically, kapag binalik natin dun sa structure na ipinakita rin sa sa module kanina, we have here our methyl, yung nasa taas kanina, yung CH2, CH3. Tapos, ito yung ating oxygen. We have here a hydrogen. Same yung itsura dun sa kabila, although mirror images lang. Okay? Hopefully, that's clear. It takes too long to set up. So, sorry. So, going back to our slides, we have here actually our a different way on how we can look into this enantiomers. So, para lang makita nyo yung scenario na nangyayari dyan, we can actually write them using flying wedge formulas. By flying wedge formulas, we can actually see here kung paano yung orientation ng ating mga compounds sa space. So, if we have here those two chiral carbons or chiral centers, Para lang alam niyo yung spelling ng chiral na sinasabi ko. That is Chiral. So, chiral centers. So, if you want the side chain to be located in the back, you just need to draw it as a wedge that is using dash lines. So we have here our CH2, CH3. Sorry for the video okay sa kapitbahay. And we have here, again, same for this one. And same for the top. So we have here CH3. And this one, CH3. And if you want the side chain to be forward, you would draw a solid wedge. So this will be our OH. And for this one, we have here an H. So this is just a projection kung paano natin sila nakikita. No? So same for this one, we will have here our H and we will have here our OH. So for the next part of our configurational stereoisomers, we have actually here the diastereomers. So for diastereomers, not unlike enantiomers, diastereomers are actually what we call uh, mirror images. Non-mirror images. So by non-mirror images, there are actually two types of diastereomers. We have here what we call the stereocenters. So for the stereocenters, it can happen that we will have here multiple chiral centers for our diastereomers. So unlike enantiomers, this diastereomers do not have what we call uh, mirror images. So some examples of this are our CHO or our carboxyl group here. So we have here our carbon again, and we have here our hydrogen and our oxygen. And example, we have here our H and OH. Then we have here our CH2O. This is actually some a sugar, if I'm not mistaken. Hindi ko na lang maalala kung anong type ng sugar siya. So kapag kukunan natin siya ng diastereomer, this one with stereocenter, uh, what will happen here is same. We will have here our CHO. Then we will have here our H. So it may look like mirror images, but it will not because what will happen here is we have here H and this OH. So we have here CH2OH. As you can see here, these molecules are not what we call here not not mirror images of each other. So basically, we have here for this one, we have here the left side is we have here an hydroxyl and hydrogen hydroxyl for this one. But for this molecule, we have hydrogen, and uh, we have here OH. So basically, they are not mirror images. So if we are to get or if we are to draw an enantiomer or a mirror image of this one, say this one, the enantiomer of this will look like this. So we will have CHO, then we have here our hydrogen or hy- hydroxyl, then we have here our hydroxyl, and we will have here our hydrogen and our CH2OH. So basically, this will be an enantiomer of this molecule. But this is not uh, this one. These are not mirror images of each other. Okay. So these are diastereomers with stereocenters. By stereocenters, as you can see here, we have here multiple chiral centers here. So this carbon actually have four different sides or different molecules that is attached to it. Same for this one. So these are the chiral centers. And also we have here this chiral center. So diastereomers actually happens when we talk about sugars. The example, for example, let's just go to the internet, the greatest source of information. All right. So let's look into the molecules of glucose and let's say lactose. Right? So let's go to the images. As we can see here, hindi pala glucose. Galactose pala dapat, sorry. Gala. Okay. As you can see here, we have here the cyclic analogs or ito pala. We have here our glucose and our galactose. As you can see, they may have they it may look like they have the same structural structure, but as you can see here, we have here our hydrogen, hydroxyl, hydroxyl, we have here hydrogen, and nabaliktad na yung form natin. And so we have here uh, OH and hydrogen. Then we have this one, we have hydrogen OH and hydrogen OH. So as you can see here, glucose and galactose are actually what we call here the stereomers of each other. So thank you to Cora.com for that visualization. So going back to our slide, where's our slide? Here's our slide. So in that, we have there our diastereomers. So there are two more kinds or two more types of diastereomers. So we have here our cis trans conformation. So that should not be like that. Let's fix that for a second. It should be cis trans for alkenes and cis trans for cyclic compounds. Alright. So in that, as you may see here, class, recording naman tayo. Fine. Anyway, for cis-trans of alkenes, for cis-trans, ang nangyayari lang actually dito ay tinitingnan lang natin yung conformation or yung tinatawag na position ng ating mga substituents when we talk about cis and trans conformation or configurations. So for cis-trans configuration of stereoisomers, if we have here, let's say, a double bond uh, for butene, let's say butene, by butene, we will have here C2, CH, and then the double bond, and we have here CH, and should be CH3, and we have here CH3. So, what it would look like kapag titingnan natin yung angles or yung 109.5 na angles ng carbon bonds. So, for the cis conformation, we will have this structure. So this one. And so as you can see here, this is what we call our cis configuration. By cis configuration, our substituents, or what we call side chains, or other molecules or same molecules, actually have the same orientation. So, kung titingnan natin dito, parehas silang nasa taas, and for trans, ganito yung mangyayari dyan. So, we have here our carbon compounds, then we have here our CH3, okay? And we have here our CH3 and our hydrogen. So as you can see here, our metals are not on the same side. By not the same side, one is on the top and one is on the bottom. So this will be our trans configuration. So bakit ba nangyayari yan? Or bakit nangyayari na nagkakaroon tayo ng cis and trans conformation when it comes to alkene? So again, give me a few moments. Okay. So for our alkenes, ang tinitingnan lang naman natin, or when we talk about double bonds, uh, ganito kasi yung nangyayari, class. So, double bonds, we will have four electrons sharing the same space. So, yun yung tinatawag nating double bond. So, we have two electrons here for this bond and two electrons here for this bond. So, as you have may remembered, kapag meron tayong single bond, dito na lang natin tingnan. Tingnan natin tong single bond ng ating carbon and oxygen. As you can see here, if we have single bonds, pwede tayong magkaroon ng tinatawag nating bond rotation. Tinatawag. So, when it comes to double bonds, that becomes a little impossible for that to happen. Kasi, as you can see here, there are four or two sides of bonds that is holding carbons together in such position. That means you cannot expect any rotation of the bonds because of that double bonds. So, that makes the trans and cis configuration possible. So, anong nangyayari dyan, kapag ang naging configuration natin ay cis, or trans pala muna, uh, magme-maintain yung trans configuration na yan unless magkaroon ulit ng panibagong tinatawag natin reaction. So, same for, yan, tinignan natin, hindi siya mag-rotate. Same for our cis configuration. So, what will happen here is if we have this uh, cis configuration, hindi rin po yan magbabago due to that double bond. Okay? Actually, tuloy na rin natin, ano? Same concept when we are talking about cyclic compounds. By cyclic compound, let's say we have here a cyclopentane. Same for our cyclic analog. So, say we have here our cyclopentane. Okay? Propane pala. So, we have here three carbons that are connected in that loop, or in a cycle, or in a circle. So, kaya siya cyclo or cyclic analog. But, for example, if we have other substituents or other compounds that is attached to that carbons, pwede tayong magkaroon ng tinatawag nating cis and trans. Okay? So, for those cis and trans, for example, this is cis. Again, same tendency. Wala tayong makikitang bond rotation about the carbons. So, basically, dahil dun sa walang bond rotation on those carbons, hindi magbabago yung cis or yung configuration natin dito. Kung nag-start na cis yung location ng ating mga substituent natin dun sa ating cyclic compound, hindi siya magbabago. So basically, what will happen is for trans naman, so for trans, same concept. Due to the impossibility of bond rotation, hindi magbabago yung configuration natin dyan. Kung yung OH natin or hydroxyls natin ay nag-connect siya in a cis way, hindi na siya, in a trans way, trans siya. Unless magkaroon tayo ng iba pang reactions, and usually naman when we talk about this one, alkanes or cycloalkanes or cyclopropane to be exact, bond opening lang ang mangyayari dito. And dun sa bond opening, pag nag-open yung bond, saka lang tayo magkakaroon ng time na pwedeng magbago yung configuration na magkatapat yung hydroxyls at yung green na yan. Okay? So, yun yung pwedeng magkaroon ng bond rotation. So, pabago-bago na yung positions nila. So, matatanggal na yung pagiging cis or trans configuration ng ating alkenes or ng ating cyclocompounds kapag tayo ay nagkaroon ng reactions. Okay? So, going back to our slides. So, in that, you can see there that when it comes to our cyclic compounds, mangyayari lang dyan kung meron tayo nung ano natin, cyclopropane. If we have a cis configuration of our cyclopropane, what will happen here is, for example, we have here our OH na ginamit natin kanina. Though medyo impossible to mix ang plus yung OH na yan. And then, yung OH ay maintain dyan sa baba. No, we're talking about cis. So, this should be OH. Okay. Then we have here our hydrogen and our hydrogen. So for the trans configuration of our what we call this cyclic analog, what will happen here? What happened is we have here our OH, we have here our hydrogen, then we have here our hydrogen and our OH. So this will be for cis configuration, and this is for trans configuration. So that is our configurational stereoisomers. So for the last part of our stereoisomers, wherein they have the same locations of bonds, they have the same molecular formula, we have here what we call conformational isomers. So for conformational isomers, what happens here is just the rotation of the single bonds. So, yung kanina kung tiningnan natin dun sa sa trans and cis isomers ay yung double bonds natin at saka yung cyclic analogs. For conformational isomers, andito na actually yung nangyayari yung tinatawag nating rotation due to single bonds. So one example here of one of the most common example of conformational isomers is what happens with let's say butane. So our butane has a chemical formula of C4. Siyempre, both of them has a confirmed of C4H10. Okay. So, ipakita natin kung ano yung sinasabing eclipse and staggered confirmation ng ating ethane. Okay? So, in that, we will be having this video again. So, going back to the drawing board. So, let's have our butane. Okay? So, for our butane, as you may have remembered, butane has four carbon atoms. So I have here four carbon atoms. And also, butane has our hydrogens. Wait lang. Okay. So we have here our butane. So usually, when we talk about single bonds, or let's say our alkenes, we have this configuration in which pasigsag siya, ano. So, but in some cases, when we talk about configuration, it it can happen that we will have an eclipse configuration and a staggered configuration. So to look into that, ang pwede nating actually gawin ay i-position natin yung ating butane or kung anumang single bond in a horizontal position. So in that horizontal position, makikita natin na merong difference or pwesto na tinatawag yung ating uh, mga other parts ng chain natin apart from our perspective here. So, paano magiging eclipse or paano magiging staggered yung position natin? So, for this one, actually, originally, or yung usual na nangyayari, if we have this butane, staggered yung position niya. Anong staggered? Magkahiwalay yung dalawa apart from or magkalihis yung dalawa apart from our this one or this bond. So, paano siya nagiging eclipse? So, upon rotation or bond rotation, kasi alam natin possible yon na pwedeng mag-rotate yung bond na to, okay? Pwede rin mag-rotate tong sa gitna at pwede rin mag-rotate tong dalawang to. Due to that, just two electrons sharing each bond. So what will happen here if we have an eclipse configuration? So that there will be a rotation of the single bond that you put in horizontal position. So this will be our eclipse position. So by eclipse position, kung naiisip niyo yung eclipse, sir, solar eclipse, ano yung nagtatapat? Actually, ganun yung nangyari. So, kung titingnan natin dito sa baba, those two metals are actually eclipsed to each other. So, at some scenario, meron tayong tinatawag na mga conformations, pero hindi ko na yung masyadong i-discuss dito. But basically, when we talk about this type of organic chemicals, ang mas preference kasi nila class ay yung tinatawag nating staggered. Bakit mas gusto ng organic compounds natin ng staggered? Kasi kung maaalala nyo, nung last time, uh, tawag dito, the same repels. So, dahil dun sa mass or dun sa dami nung, nung ating mga hydrogens and yung electron cloud and something, yung mga ganun, may interaction in between dito. So, when it comes to configuration, mas preferred ng mga molecules yung ating staggered na location na ano. Kaya kung mapapansin niyo pag nagdo-drawing ako ng chemicals, laging pasigsag. It's because of that. Because of the 109.5 degrees of bond locations when we talk about carbons. So, yun yung dahilan kung bakit siya zigzag. So when it comes to our alkanes, meron tayong tinatawag na cyclic analogs. So for cyclic analog, pwede actually mag-exist na magkaroon tayo ng cyclic analog and then meron pa rin siyang configuration na tinatawag. So let's take for example our pwede natin gamitin ang cyclohexane. So by cyclohexane, so we have here 1, 2, 3, 4, 5, one more. So for cyclohexane, we will have here a cyclic analog in, ano nangyari? Kulang sila ng hydrogen. Alright. Okay? So, what will happen here actually, kung titingnan nyo, possible yung bond rotation dun sa mga bonds natin. Though hindi ganun karami, kung mapapansin nyo. Pwede silang mag-twist and turn yung ating cyclohexane. Bakit siya cyclohexane? Kung makikita natin, we have here 6 carbon atoms and yung mga whites, yun yung ating hydrogen. So, it's purely carbon and hydrogen na nagpo-fall siya sa ating alkanes kasi wala rin siyang double bonds. So, kung mapapansin nyo, about dun sa single bonds natin, pwede actually magkaroon ng tinatawag nating bond rotation. So, due to that, meron tayong ding tinatawag na conformational uh, isomeric na itsura ng ating hexane. So kung makikita niyo kung ginawa ko siyang basta lang hexagon, merong twisting na nangyayari. So, actually, pwede tayong magkaroon ng tinatawag natin ganyan. So, kung titingnan natin actually, pwedeng ganyan, pwede ring ganyan yung maging itsura ng ating cyclohexane. Merong sa baba, tapos merong nakataas. So, pwede nyo actually tingnan na basis dun sa taas at baba ay yung ating mga hydrogen. Okay. So, paano ang staggered, paano ang hindi staggered dito? So, para mas makita natin, gagawan ko ng, lalagyan ko ng green dito sa isa. And also, green dito sa isa. Okay. So, as you can see here, this is actually staggered confirmation. Kasi kung titingnan nyo tong, ano na to? Ito, and ito, sila ay nasa horizontal. And kung titingnan nyo naman yung dalawang green, nasa baba sila parehas. Okay? So basically, this will be the, tawag dito, this will be the staggered confirmation of our cyclohexane. So, ano yung magiging itsura ng ating, yung magiging itsura ng ating eclipse? So, for the eclipse confirmation of our cyclohexane, ang mangyayari ganito. So, meron dalawang nakaangat na parts nung ano natin, nung cyclohexane. So, yung dalawang green na yan. So, kung titingnan natin siya from one side, eclipse sila sa isa't isa. Okay? Hindi katulad nung staggered kanina na naging itsura ay ganito. Okay? So that is how we can look at the staggered and eclipse confirmation of single bonds. So kanina, pinakita natin yung sa butane. Ngayon, ito yung sa cyclohexane. So paano natin ito i-drawing? Okay, so pakita natin kung paano natin i-drawing. Balik tayo sa ating slide. So, para dun sa sa eclipse ng ating C4H10, meron tayo actually dalawang way kung paano isusulat yon. Pero ang ituro ko na lang ay yung isa kasi yung mas madaling i-drawing at mas madaling intindihan. But basically, we have two types of we have two types of projections na pwede natin ipakita. So we have the Sohor's confirmation. So, course, ibig sabihin yung lagarian. And also, we have the Newman projection. So, pakita ko yung sa Sohor's kasi ito yung mas madaling tingnan. So, may Sohor's, if we are to draw the eclipse configuration of our butane, what will happen here is you just need to draw a line. So, we have here our carbon and another carbon here. So, pag eclipse, tapat. So, we will have here our CH3 and another CH3 here. Then we will have here yung mga paa kasi sawhorse nga siya. So we will have here our H and another H here and another H here and another H here. So, paano naman yung staggered? Ganun lang din. You just need to draw uh, two carbon here. Then we will have here pwedeng dito sa taas yung ating CH3 na to. Then we will have here our hydrogens. Then, ano mangyayari dun sa, ano dito? Baliktad lang. So we'll have here our CH3 and we will have here our H. So, paano yung sa cyclohexane? Meron dalawang way kung paano gagawin yon. So, for the Eclipse, ito yung mas madali tingnan. But basically, we have here for the Eclipse, drawing ka lang ng boat. So, that will be the Eclipse configuration of our cyclohexane, wherein each of the corner of that boat is actually a carbon atom with the hydrogens that is attached to it. So, mangyayari lang dyan, dito yung isang hydrogen, dito yung isa, dito yung isa, sa baba yata. Then, we have here this one, and this one, then this one, and I think this one. Then we have here a hydrogen, 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 and hydrogen. But basically, you can just draw the both and yun na yung itsura niya. So for the staggered of our cyclohexane, it will look like this. So yung isa po ay nakababa, sabi natin kanina. Then we still have that somehow both confirmation. Then that one. So basically, it will look like the messenger logo. But anyway, ulitin lang natin kung paano ginawa yan. So we have here that one, this one, and then this one, and that one. So again, each corner of this confirmation or this drawing is actually a carbon atom. So we have here the eclipse, which we call both confirmation. And this one, the staggered, which can also be called as chair confirmation. Kasi it resembles a chair. Kung titingnan natin. Basically, that's it. That's all of the isomers. So, on our past video, we have talked about skeletal or tinatawag natin structural or constitutional isomers. For today, we actually finished talking about our stereochemical or stereoisomers. So wherein we talked about configurational isomers when na pinag-usapan natin ang enantiomers at diastereomers. Wherein for diastereomers, we have those with stereocenters like our sugar, like glucose and galactose. We also have the cis-trans conformation, wherein we talked about the double bonds and the cis-trans isomers of cyclic compound uh, like cycloprophane, like earlier. And also, we have our conformational stereoisomers wherein we talked about the bond rotations or the conformations or the isomers that is formed by uh, the rotation of single bonds. So basically, that's all of the isomers that we will be dealing with in organic chemistry. So, in that, I will be ending this lecture here. So, hopefully, you have a nice day. Bye.